Hello everyone, I am Tahira Mazumder from IT department, AKGEC Engineering College. Today I'll be talking on the topic of data link control, which is a topic which comes under computer networks with subject code KCS 603 under AKGEC. To start with, first I will give a brief introduction about the index on which I'll be talking about. First I'll be talking about what exactly data link control is. I'll talk about framing, the concept of framing, flow and error control, then I'll talk about, and then I'll talk about some protocols, noisy and noiseless protocols, and I'll take up some protocols in depth. Okay. To start with, let us talk about what exactly data link layer, the role of data link layer. So if you remember, we have learned in the OSI model basically has got 6 layers, starting from the physical layer in the lowest level to the application layer in the highest level. So data link layer comes between the physical layer and the network layer. Fine. So the role of the data link layer, so if you're in a computer, if you're in network, when you are in a network, we have the sender sitting at one end of a system. We have a sender sitting at one end, and we have a receiver sitting in a machine in the other end. So at the sender's end, from the sender's end, data flows from the application to presentation layer, from presentation to session layer, and so on, and then it goes to the physical layer. Now, at the sender's end, when you're talking about this part, for example, from the network layer, the data goes to the data link layer. The data link layer, from the data link layer, it goes to the physical layer, and the data that is being communicated over the physical medium. The physical medium can be anything. It can be wired medium or it can be wireless medium. And at the receiver's end, from the physical layer, the data is now transmitted, or the data faces the data link layer, then followed by the network layer. So, so this is where the data link layer exists. And what are the services that the data link layer provides? It provides the concept of framing, reliable delivery, handling of flow control and error control, taking care of half duplex and full duplex mode of communication. So when we're talking about data link layer in more detail, what are the devices that works for the data link layer? Some of the devices are switches, bridge, and so on. The services, as I already told, framing, error control, and flow control. Today I'll be talking more on these topics. The functions of the data link layer is to provide a well-defined service, which is an interface to the network layer, as we have already seen in the previous slide. It deals with transmission errors and the regulation of flow of data from one layer to the other layer. Now, the data link layer can be divided into 2 types, or rather we can say it can be we can look at it as being made up of 2 layers. One is the logical link control layer, and the other one is the MAC layer, or also called as the media access control layer. The logical layer, basically, it is responsible for handling flow control, error correction, and so on. And the media and MAC layer, it is responsible for providing a medium for the stations to transmit data from one end to the other end. It gives a medium or access medium via which the data will be transmitted. In today's class, we'll be talking about this part, the logical link control, where we'll talk about the flow control and the error control. Now, to start with, first let us talk what exactly framing is. As I told you, first we'll talk about frames, and then we'll come up with the protocols. Now, the frames. Now, we need to think that in the data link layer, what we do is that we pack the bits into frames. That means the communicating units in the data link layer are frames. What are frames? Frames are collections of bits, and we need to have a method to distinguish one frame to the other one. Now, if you consider a post office example, which is a very standard example that we all have learned when you are talking about OSI model. So in that example, we can say if you are trying to send a letter from one destination to the other destination, what we do is that we type the letter, we insert the letter in an envelope, and the envelopes are sent from one place to the other place, and via the envelopes we distinguish the letter from one letter to the other letter. So this framing does somewhat this kind of work. It distinguishes one frame from the other frame. Frames are basically collections of bits. We can also say one frame similar to an envelope which holds a letter in the example of post office. Now, there are if you look at the types of frames, we have this fixed size and the variable sized frames. So in fixed size frames, as the name indicates, here there is the size of the frames are fixed. The frame size are fixed. So if the size are fixed, then it is being agreed upon both by the sender and the receiver what is the size of the frame. So we don't have the need for defining the frame size with every transmission. That is not required because the frame size is fixed and it is agreed upon. For an example of fixed size framing is the ATM WAN network, which uses frames of fixed size. Now let us come to the concept of variable size frames. This is more prevalent in LAN or local area network. Here the frame size is not fixed or not pre-decided upon, so we need to find a way to define the end of the frame and the beginning of the next frame. So these are some concepts which I looked upon in case of framing. And when you're looking at framing, we have these two kinds of approach. One is character oriented approach and the other one is bit oriented approach. For today's lecture, I'm not talking much about framing. I'll be talking about protocols. Now, so let us now talk about flow and error control. Fine. So one of the most important responsibility of the data link layer are flow control and error control. And this flow control and error control role which data link layer provides, these functions are collectively known as the data link control. So data link control basically refers to the flow control and the error control. So what do you mean by flow control? Flow control basically refers to the set of procedures that are used to restrict the amount of data that the sender can send before waiting for an acknowledgement. We all know we have the sender at one end of the network. We have the network here. This is a sender sitting at one end, sitting near his own machine, instead in front of his own machine. And we have the receiver at the other end sitting in his own machine. Fine. So this is your receiver and this is the sender. Now in this task, and we are using the computer networks for communicating between the sender and the receiver. So here the flow control basically it is looking upon the set of procedures which ensures that as the data is being transmitted from the sender to the receiver, how much amount of data can be transmitted before we have an acknowledgement signal coming from the receiver to the sender. So it focuses on the amount of data that the sender can send before waiting for an acknowledgement, or rather to ensure that the sender is sending an amount of data which the receiver can actually accept and it is not overflowing. Now error control basically it is again a service provided by the data link layer, and it is based on normally an automatic repeat request, which I'll be talking more in the subsequent slides. So error control basically focuses on error detection and error correction. So in this concept, we are allowing the receiver to inform the sender if any frames are lost or damaged during the process of transmission, and coordinates with the receiver for the retransmission of those frames such as sent by the sender. So when you are talking about error detection and error handling in terms of data link layer, we are basically talking about handling of frames and ensuring whether the frames are being received or not. If the frames are not received, that the frames are retransmitted, and this is how error handling is being taken care of in data link control layer. Now let us talk more on protocols. So we all know what are protocols. Protocols refers to what? Protocols refers to a set of rules. Fine. So we refer to protocols in the case of data link layer. What we do is that when you're talking about protocols, we combine framing, flow control and error control. So whatever protocols we'll be talking for data link layer or data link control, we'll be talking about combining protocols, combining or rather having the features of handling framing, flow control and error control to ensure that the required data is being delivered from the sender to the receiver. The protocols are normally, these protocols are how, now if we have the set of rules, protocols are set of rules. Now how do we ensure that these rules are being followed by the computer system? We all know that a computer system has got two important components, the hardware and the software part. So when it comes to the protocols which we will be using for ensuring proper delivery of data in the data link layer, those protocols are being taken care of by the software. Fine. So we have a set of codes, set of lines of code which ensures that the data that is being sent from the sender send to the receivers and at the data link layer takes care of framing, flow control and error control. So the software, because softwares are program based, which will vary from machine to machine, which will vary from programming language to another programming language. So we will not focus in the next lines, we will not focus on the programs, rather we will focus on the pseudocodes or the algorithms which are independent of the syntax of any particular programming language. Now, let us talk more about the protocols, the taxonomy of the protocols, the classification of the protocols with respect to the data link control layer. Now, the protocols can be briefly divided into two types. One is for the noiseless channel and the other one is for the noisy channel. Now, we all know what are noiseless and noisy channel. In case of noiseless channel, it is an ideal channel which is devoid of any noise in the medium, and if there is no noise in the medium, we ensure, what does having no noise in the medium mean? Having no noise in the medium mean that there will not be any errors in the data transmission, and we will have a free flow data flow without any issues arising out of flow control and error control. So for noiseless channel, we will be talking about two protocols, the simplest protocol and the other one is stop and wait protocol. These are two protocols which are very ideal protocols for noiseless channel. But and another point to be noted is that these protocols, they are non-existent because we never have a channel which is totally noiseless, but we take it as a benchmark to compare our protocols which are meant for noisy channel. So under noisy channel, we have some important protocols, namely stop and wait ARQ, go back and ARQ, and selective repeat ARQ. Stop and wait ARQ means automatic request. ARQ stands for automatic request, right? So we have these three protocols that comes under noisy channel. Now, because of timing issues, so I will be talking about the first two protocols for noiseless channel, and I'll compare with one of the protocol here. We'll compare with stop and wait protocol. So basically, I'll be comparing stop and wait protocol for noiseless channel versus stop and wait protocol, which is also called as stop and wait automatic request protocol for noisy channel. I'll not talk more on go back and then selective repeat ARQ for the time being because of time constraints. Maybe in some of the slides or in some of the lectures, I'll take up a comparison between the other two protocol, go back and then selective repeat. So for now, we'll start with the first two. So we now start with the first two, that is for noiseless channel. So in case of noiseless channel, what we are assuming that we have an ideal channel which never actually exists, but we are still taking that example. Why so? Because we will be comparing it as a standard for comparing our protocols for realistic world. Now, so and noiseless channel is basically an ideal channel in which there are no frames that are lost, duplicated or corrupted. That means all the frames are sent error free. So excuse me, for handling such protocols, we'll say for dealing with noiseless channels, we introduce two protocols, namely the simplest protocol and the stop and wait protocol. Now let us start with the simplest protocol. The simplest protocol, it is meant for noiseless channel, as I told you. Here, the sender sends sequence of frames without even thinking whether the receiver has received or not. So if you look at this example, the sender is sending 3 frames and the receiver is receiving those frames. And if you look at it, we have this lines, we have a slanting line, not exactly a straight line. Why? Because there is a time gap. But at the time in which the frames are sent, obviously, the frames will be received at a later time, and hence we have a slanting lines. So here we just have 3 events. For example, we want to send 3 frames. So we have 3 events at the sender's end and 3 events at the receiver's end. And the 3 events at the sender's end is corresponding to the request for sending, and at the receiver's end is corresponding to the arrival signal. This is how a simplistic protocol looks like. We have, as I again told, we are in a part, this is your OSI layer, and we have the physical, the data link layer and network layer. On top of it, we have other layers, right? We already have talked about the transport layer, application layer, session layer, and so on. But right now we are focusing on the lower 3 layers. The data link layer lies between the physical layer and the network layer. So this is at the sender's end and this is at the receiver's end, fine? So at the sender's end, obviously the data will come from the network layer, go via the data link layer and come to the physical layer. So At the sender's end, the data link layer will get the data from the network layer and transmit it to the physical layer. So the algorithm at the sender's end will wait for request for data transmission from the network layer. Now at the algorithm at the receiver's layer, the data flow will be in the reverse direction. From the receiver frame, from the physical layer, it will go to the data link layer, and then it will go to the network layer. So the algorithm, or rather the programs which are running at the receiver's end, they will wait for notifications coming from the physical layer that there is data that has come via the physical medium and needs to be taken care of by the data link layer. And here, since it is a simplistic protocol, we have data frames that are being transmitted in unidirection from the sender to the receiver. There is no need to send any acknowledgement signal because we are assuming that the data are being transmitted error free, and we are confident all the data frames that are being transmitted will be received by the receiver. This is the algorithm that is taken care of for the simplistic protocol. We have a sender algorithm, we have the algorithm at the receiver's end. At the sender's end, the algorithm is here. We are talking about the sender. So if you see at the sender, what happens? The sender waits for a request from the network layer. Once data comes from the network layer, it starts taking care of. So the sender waits for an event. What is the event? It is a request from the network layer. This event is a request basically from the network layer for data transmission. Once such a request has come, the request to send has come from the network layer. Why? Because it is at the sender's end. Once such a request has come, then the sender or the algorithm at the sender's end will get the data from the network layer. The data will be coming from the network layer. In that case of network layer, the data unit transmission or the unit of data transmission is packets. What it will take the data, it will convert them to frames, and then it will send the frame. This is which is happening at the sender's end. Now, at the receiver's end, if you look at the receiver, at the receiver's end, the data is coming from the physical layer, and then it is to be delivered to the network layer. That means the notification which will be coming for receiving the data will be coming from the receiver's end, or rather coming from the physical layer. So at the receiver's end, again the algorithm that is running, it will wait for an event. And what is the event? The event will be a notification that will come from the which layer? From the physical layer. Fine, because why so? Because it is at the receiver's end. Once such a notification come, what is a notification? Because it is from the receiver's end. So once such a notification come, we are calling that notification as arrival notification. Once that notification comes, that means the data frames are being received. Once a notification comes, so what it will do? It will receive the frames. The data link layer will receive the frames. From the frames, it will extract the data, and then it will deliver the data to whom? If you remember, if you see the slide, it will deliver the data to the network layer. So it will extract the data and deliver the data to the network layer. So this is how this simplistic protocol works, a very, very idealistic protocol which is non-existent. Now let us go take one more protocol which is again an idealistic protocol that works for noiseless, or rather noiseless channel. We call it as stop and wait protocol. Here the sender, it sends one frame at a time and waits for a feedback, or rather for an acknowledgement from the receiver. The sender sends one frame, waits for an acknowledgement. The sender sends next frame and waits for an acknowledgement. That means we have one more kind of signal, that is an acknowledgement signal that is being sent from the receiver to the sender. Now here we still are assuming that it is an ideal channel which is error free, but we have now more number of events. If you just see at the sender's end, we have 4 events that is coming at the sender's end, and if you look at the receiver's end, we have 2 events. Unlike the idealistic channel which is having 3 for 3 transmissions, at the senders, if you look at the now for stop and wait, for 2 transmissions, if you just see, it is 4. Had it been 3, then it would have been 6, fine, at the sender's end, and here it is 2 at the receiver's end because of 2 transmission. Had it been 3, then it would have been 3 signals. So this, what are those events? At the sender's end, it is a request to transmission, and the next it is an arrival of acknowledgement. Once the arrival of acknowledgement comes, then request for the next transmission, and then arrival of the acknowledgement. And receiver's end, once the data is received, the receiver will send an acknowledgement signal. So here we have this extra new signal which is called as the acknowledgement signal. So this is how we have at the sender's end, we have this is at the sender's end and this is at the receiver's end. So at the sender's end, the data link layer gets the data from the network layer and makes the frame and sends the frame to the physical layer via which the frames are being transmitted in the transmission medium. And then at the receiver's end, the frame reaches the physical layer. From the physical layer, the frames enters the data link layer, which will be delivered to the network layer. Now, so in the algorithm for the sender's end, it will request what? It will wait for a request that is being sent from the network layer. And what else it will wait? It will wait for a notification, which you also call here as the acknowledgement signal, that is coming from the physical layer. Now, what about the algorithm at the receiver's end? The algorithm at the receiver's end will wait for the arrival for a notification from the physical layer indicating that the frames have arrived from the physical, from the sender. Fine. This is the algorithm for the sender at the receivers for stop and wait protocol. Now, when you're talking about stop and wait protocol, we are taking the algorithm while through means it is an infinite loop which will continuously send. That means senders and receivers are always in the mode to send and transmit data. So while we are going for an infinite loop, we are taking a flag variable can send. Initially, excuse me, we are setting this flag variable can send to true. Then what we do, we wait for an event. What is the event here? We are talking from the sender's end. So the event is what? At the sender's end, the event is what? The event is a notification coming from the network layer that it wants to transmit data. So the event is a request to send which is coming from the network layer, and this is a new thing that is happening if you compare it with the previous algorithm, and it checks what is the value of the Boolean variable can send. If the value of the Boolean variable can send is true, if this is true and if this is true, then only this if structure will be executed. So what does this if structure do? It gets the data from whom? It gets the data from the network layer, gets the data, makes the frames, sends the frame, and once one frame is sent, it cannot send one more frame till the acknowledgement has been received. So to do so, it is using the flag variable can send, which is set to false. It will be false now because the frames are being transmitted. It will be set to true once an acknowledgement from the receiver has been received. So once can send is true, false, and then once it is out of the if, it waits for an event. For what event? The event is acknowledgement signal coming from the receiver. So if the event is actually an arrival notification, this acknowledgement signal, we are calling it as arrival notification coming from the receiver. If this event is an arrival notification, what the sender will do, excuse me, what the sender will do if there is an arrival notification coming from the receiver, so what the sender will do, it will receive the frame, that means it is the acknowledgement, that is it is receiving the acknowledgement frame coming from the receiver, and then the acknowledgement has been received now, so it is now ready for making another new transmission. So what it will do, it will set the can send flag variable back to true. This is what the algorithm that works at the sender's end. And if you look at the algorithm that works at the receiver's end, again we are entering an infinite loop. Now if you look at the receiver end, the data will be coming from the physical layer and then it will be delivered to the network layer. So at the receiver's end, it waits for an event. What is the event? This trigger coming from the physical layer. The event is an arrival notification from the physical layer. Fine. So once the data has come from the physical layer, if you remember, frames are being transmitted via the physical layer. So what the receiver does, it receives the frames, extracts the data from the frames, and then this data is being delivered to the next higher layer, which we are calling it is the network layer. And then once the data is delivered to the network layer, it next sends an acknowledgement frame to the sender. Fine. Now that till now we have talked about noiseless channel and noisy channel. Now we'll come to the actual channel, which we call it as a noisy channel, which actually exists in real life scenario. So here for noisy channel, in case of noisy channel, we are saying that we have to handle flow control and error control, because there is a chance that we cannot ensure that the data is being transmitted error free, or there is a chance that the acknowledgement cannot be received, and so there might be corruption of data, loss of data frames, and so on. So to handle all these scenarios, we have these three protocols, namely stop and wait ARQ or automatic request protocol, go back and ARQ, and selective repeat ARQ. for today's class, I'll be talking about stop and wait ARQ. Okay, so let us start with stop and wait ARQ. Now, stop and wait ARQ basically is similar to the previous one, which we talked about, noiseless channel, which is called as stop and wait. It is similar to stop and wait, but it handles flow control and error control. So what is a new thing that we have? We have an extra mechanism which will take care of flow control and error control. How do you handle error control? Here, error control is handled by keeping a copy of the sent frame. The frames are sent and we don't delete the frames. We wait for receiving the acknowledgement of those sent frames, and only after receiving the acknowledgement of the sent frames do we delete the frame. And if no acknowledgement are being received, we retransmit the frame once the timer is being expired. So this is how error correction is being taken care of in case of stop and wait ARQ. So for doing so, we use sequence numbers of base 2. That means if sequence number fluctuates between 0 and 2, the sequence numbers are modulo. So since it is in base 2, we call it as modulo 2 arithmetic. The sequence numbers it fluctuates from 0, 1, 0, 1, 0, 1, and so on. I'll take up example and show it to you. Here, the acknowledgement number is also using the same number. So we have this sequence numbers taken care of both at the sender's end and the receiver's end. At the receiver's end, we call it as the acknowledgement number, which also works in modulo 2. So it also deals with numbers like 0, 1, 0, 1, 0, 1, and so on. So this is how you have, this is the design of the stop and wait ARQ. We have the data link layer. We have data coming from the network layer to the physical layer via data link layer at the sender's end, and vice versa at the receiver's end. The new thing that is coming up is the timer, which was not there in the previous algorithm. And next new thing is sequence number given to the frames at the sender's end and acknowledgement number given to the frames at the receiver's end. So what happens is that as we transmit the data, the frames that are being transmitted will be having the header, the frame data, and every frame that is being transmitted will be having sequence numbers. Similarly, every acknowledgement that is being received from by the sender from the receiver will also have the acknowledgement number, which we call it as RN here. Fine. So here, as we like for example, here if you look at it, as we are saying, considering that it is an ideal channel, so there is a chance that the frames can be corrupted and lost, and so we need to take redundancy bits and also a sequence number. Now the acknowledgement frames, as I told you, it also has a sequence number. In this protocol, the sender, for example, if simply discards a corrupted acknowledgement frame, or it also discards or ignores an out of order acknowledgement frame, the sender, as I told you, it keeps a copy of the frame as it is transmitted. It waits for the acknowledgement, only then does it discard, and we use sequence number and acknowledgement number at the sender's end and at the receiver's end. And this sequence number, we name it by SN at the sender's end. SN will be pointing to the next frame that is to be transmitted, and in the receiver's end, we call it as RN, which is at the receiver's end. It is pointing to the next frame that is expected at the receiver's end, and it will hold the number of the next frame that is expected, and SN holds the sequence number of the next frame that is to be transmitted. So if you look at the algorithm for stop and wait ARQ, so we have a new variable SN, the sequence number at the sender's end. We initialize it to 0. That means the 0th frame will be the first frame that will be transmitted, and we have the scan send boolean variable, which is true, and infinitely we are entering an infinite loop. Well, because we are assuming that continuously sender and the receiver will be in a mode to receive and transmit data. So the sender waits for an event. What is the event? A trigger coming from the network layer, that data is to be transmitted. Once the trigger comes, which you call it as request to send, which is coming from which layer? From the network layer, and this flag variable is true. That means no data acknowledgement frame has been sent, or it is the first transmission. Once the trigger comes, the sender gets the data from the network layer, makes the frames out of it. Which frame? Frame with sequence number 0. Initially it is 0, so initially the 0th frame will be made. The frame, since we have to wait for an acknowledgement, if the acknowledgement is not received, we have to resend the frame. So before, we will not delete the frame once it is transmitted, we will send the frame. So we are storing a frame. Since initially SN is 0, we are talking with frame number 0 now with respect to frame number 0. In the next transmission, it will move on to frame number 1. Stores the current frame, sends the current frame, stores it for the backup, sends it to the receiver then, and once the frame is being transmitted, the timer is being initiated. A timer, it is set to a predefined time for which the sender will be waiting for the acknowledgement to come. And once the frame is being transmitted, SN will be incremented. The frame is being transmitted now, we'll be waiting for the acknowledgement before the next transmission starts. So what you're doing, we are sending the can send flag variable to false, fine, and it waits for an event. Once an event comes, the can send flag variable will be reinitialized to true. Now this is the algorithm that is being taken care of at the receiver side. At the receiver side, we have this the request number, or rather the acknowledgement number, or the next frame that is to be received. We are setting it to 0. Then we are entering an infinite loop where you are waiting for an event. What is the event? It is at the receiver's end. So the event will be a signal coming from the physical layer. Fine. Now once such an event comes, what will the receiver do? It will receive the frame from the physical layer, because we are talking from the receiver's point of view. And if that frame, it will see, if that frame is corrupted, it will go into a sleep mode. Then it will check what is the sequence number of the frame that has come. It is matching with the, if this sequence number is matching with the sequence number which the receiver is expected, that is given by Rn variable, if it is matching, that means the frame which is coming from the sender is the frame which the receiver is expecting. In that case, the frame will be taken care of, will be taken, the frame will be delivered, will be extracted, the data from the frame will be extracted, and the data will be delivered to the next higher layer, which we call it as the network layer, and then Rn will be incremented. And after this, what happens? Since the frame is being taken care of, we are sending an acknowledgement frame to the receiver after incrementing of Rn. So if initially Rn is 0, Rn which will be sent will be 1. So if you look at it, this is the flow diagram of a stop and wait protocol. This is, I'm taking an example to explain the flow diagram of stop and wait protocol. We have the sender and the receiver. So we have the example of some frames. So let us say initially SN value is set to 0. That means the first frame that is to be transmitted is frame with sequence number 0. So the 0th frame gets transmitted. Initially, if you remember, Rn is also set to 0. Rn is also set to 0. So Rn is also set to 0. The moment a frame is received, if you just see, excuse me, if the moment you receive a frame, Rn is incremented. So Rn frame is received. So Rn now from 0 it is incremented to 1. That means I am now waiting for the next frame, frame number 1. So an acknowledgement is being transmitted. Once an acknowledgement is being transmitted, once the frame is being transmitted, as if you look at the sender's algorithm, once the frame is being transmitted, the timer is initiated, SN is incremented. So once the frame is being transmitted, the timer is initiated, SN from 0 it gets incremented to 1. Fine. Now that means the next frame, so 0th frame transmitted, waiting for the frame number 1. So frame 1 transmitted, here receiver is waiting for frame number 1, and here in this case we are assuming that the frame number 1 it has lost in the transmission medium, maybe because of various noise or so on. So after a certain amount of time, when the timer that is fixed, the time period for which it was fixed, if the timer expires, then what happens? No acknowledgement is been received by the sender from the receiver. So that means it is assumed that frame number 1 has been lost. So what the sender does, the sender retransmits frame number 1. So that means after retransmitting frame number 1, it initiates the timer, and SN from 1 it is now set to 0. Now frame number 1 is being retransmitted. Once frame number 1 is being received, Rn is becoming Rn plus 1. So Rn was 1, now it is equal to Rn is equal to 0. Why? Because we are talking about modular transmission. So 1 plus 1 will be 0. So next frame to be acknowledged is 0. So it will set acknowledgement number is 0. That means the next frame that is being expected is the 1th frame. So once the acknowledgement is being received, the next frame that is being acknowledged, or if the acknowledgement number is 0, that means the next frame that is expected is the 0th frame. That means, and once we are getting the acknowledgement time, the acknowledgement signal, the next frame that is the 0th frame that is being transmitted. Now once this is received, Rn will again be incremented from 0, it becomes 1, and so Rn is 1. That means the next frame that is expected is 1th frame. So whenever here, give me a moment, here Rn1 means that the next frame it is expecting from the sender is with sequence number 1. Acknowledgement number 0 again means the next frame expected is with sequence number 1. Acknowledgement number 1 means the next frame that is expected is with sequence number 1. excuse me. Now, after a certain amount of time, let us say this acknowledgement has not been received by the sender. The acknowledgement gets lost. So, the timer continues to run. Once the timer expires, the sender does not receive an acknowledgement. The sender presumes that, yes, the frames, either the frame is lost or the acknowledgement is lost. The result is same. It is taking considering as same. So, what it does, whatever frame has been sent, it retransmits the same frame again. SN0, that means the same frame is being retransmitted. Once this frame is being retransmitted, RN now gets frame is being retransmitted. So RN it was 1. So because it is the same frame now, which was it was expected, so RN does not make any updation. If you just see this point, so here what it will do, excuse me. So what will do? It will send acknowledgement number 1. So again, in the next case, the sender will send a frame with sequence number 1. So this is how it works. Okay, frame 0, 0th frame sent, waiting for the 1th frame. Frame 1 sent, lost. So after some time expires, frame 1 again resent, and then waiting for the 0th frame. 0th frame again sent, acknowledgement is lost. So 0th frame is again sent, resent, and then the acknowledgement is being received. This is how we have this working, the flow diagram that goes on into the working of the stop and wait ARQ. Similarly, we have a little bit more complexity for the other two protocols, which is also called as go back and selective repeat. We'll be talking more on that and maybe in some of the slides or in some of the classes. For the time being, I'm winding up on this. These are some of the references book which I've referred. I've referred Ferozan, Data Communication Networks. I've also referred Tenenbaum book and Ross book. Thank you for now.